Here are a few more applications for related rates. Each side of a square is increasing at a rate of 6 centimeters per second. At what rate is the area of the square increasing when its area is 16 centimeters squared? So we have a square. Not a very good square, but you get the idea. Each side of the square. So I'm going to call that S. So we're going to say let S be the side of a square. Is increasing at a rate. Okay, so that's the rate. So that's ds dt. Of 6 centimeters per second. At what rate is the area? Well, area, that would be dA dt of the square increasing when its area is 16 centimeters squared. So we know that this is in reference to time because it's centimeters per second right here. Now what we need to do is figure out how are sides and area related. So if we have a square, the area of a square is the side dimension squared. So that's how they're related. The derivative of the area would be dA dt. And the derivative of s squared would be 2s. And then the derivative of s with respect to time, ds dt. Now let's put in what we have, and then we'll figure out what else we need. So dA dt is what we're trying to solve for. That's going to stay dA dt. 2s. I don't have an s. I need to figure out s. So let's figure out s. We know that the area is 16, and we know that that is s squared. So if we take the square root of both sides, we'll have the area of the side is 16, or excuse me, the area of the square is 16, so the length of the side is 4. Now we know we don't need the negative because we can't have a length of a side being negative 4. So just 4. We figured out s, and we're told that ds dt is 6. That's part of our given information. So 4 times 2 is 8 times 6. It looks like dA dt is 48, and it would be centimeters squared, and then our time per second squared. Let's look at the next one. The length of a rectangle is increasing at a rate of 8 centimeters per second, and the width is increasing at a rate of 3 centimeters per second. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle increasing? All right, there's a lot to digest here. So let's just draw a picture and then we'll read it again and get our labels and see what all we can figure out. So there is a rectangle. The length of a rectangle is increasing at a rate. Length, rate, that's dL dt. Of 8 centimeters per second. And the width is increasing, so that's dW dt at a rate of 3 centimeters per second. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area increasing? So area is going to be dA dt, and that's what we're trying to figure out. How do we figure out the area of a rectangle? We need a formula that's going to relate these sides. Well, the area of a rectangle is length times width. Now this is going to be a product rule right here, first and second. The derivative of A, the derivative of area, is dA dt. First times the derivative of the second plus the second times the derivative of the first. All right, we've got our derivative. Let's put everything in. We're trying to solve for dA dt. So we'll leave that as dA dt. L, we're told, was 20. dW dt we found was 3. W is 10. And dL dt we found is 8. So let's see what we get here. 20 times 3 is 60. 10 times 8 is 80. So it looks like we have dA dt equaling 140 and that would be centimeters squared per second squared.